Okay, so the first video is about causal diagram, and before I'm moving on to causal diagram, I want to show you how classical problems are going to be captured without causal diagram. So we're all aware of the swim lane process, and what we are going to do if we want to depict any problem is defining all the element or business unit that are part of the problem, and then we are going to start somewhere with an event and go linearly from task to task that each one of the business unit are performing. And obviously one of the work that we are going to do is to figure out whether any type of those tasks are getting a certain input and providing less output, and then we try to figure out what's wrong with that. And this is the classical analysis way to resolve problems, which is very applicable to simple scenarios, but a little bit of not a fit to complex scenarios. So the first element is the causal diagram, as I mentioned before, and this is a very simple example of causal diagram. What this causal diagram is doing is depicting a classical problem with purchasing, where purchasing is struggling to provide all the request contract by IT and marketing, especially when companies are going through transformation or major changes. What you see here is a linear approach that depicts more or less the same problem that we saw in the process, but in a completely different way. And it's pretty simple diagram. All it has is a variable. Each variable contains something that contains something else, which is in this specific example business unit that contain contracts. And each and every two variables are connected in something that we call a loop, which means that marketing is influencing SS&P or purchasing, and purchasing in return influence marketing. You can see that those lines have or minus or plus signs. And if it's minus, it means that there is a negative impact. And if it's a plus, there is a positive impact. And as you can see here, marketing has a negative impact of purchasing by asking too many contracts that purchasing can't process. And since SS&P or purchasing can't process all the contract, they backfire back into marketing and badly impacting marketing or disabling marketing to have all the contract that they need in order to perform their work. So that's a negative loop. You can see that most of the loops here are negative, which is a bad sign. Some of the loop can be, so this is called a reinforcing loop. It's an important thing because reinforcing loop are or increasing or decreasing something in the system. And you definitely want to have a balance between the number of increasing and decreasing reinforcing loop. One of the type of the loops that we don't see here but exist is a loop that has minus on the other side and plus on the other side. We call it balancing loop. So those loops will create balance in the system. They won't have any growth. And usually in a system you want to look for certain number of reinforcing and balancing loop that depict what the system wants to achieve. So in this particular scenario, you can see pretty easily that all the reinforcing loops are negative, which means that this system is pretty misbehaved. So that's one thing that loops are very beneficial. The second thing is that the causal loop has the idea of archetypes, which is pattern that known to be a problem. And each and every archetype is coming with definition of what wrong and what can be done to fix it. So what you see here is the purchasing in the middle and the two green on above and the two red and below called starvation. And that's a classical pattern where there are a lot of requests from one element in the system, and this one element in the system is depend on two other elements that are not able to meet up with the request, which means that the middle one is starving and his performance or their performance is degrading because of two other business units. And the way to resolve it is pretty simple, is to take responsibilities or accountabilities that those two, the red ones, are doing and shift them to the green one, so less work is being done on the red one, and then the system will be much more efficient. Causal diagram also have delays, and delays are extremely important because every delay is actually a problem in the system due to the fact that human beings are very bad in understanding how A impact B if there is a delay inside. Usually they don't see it. So if the impact is coming pretty soon or pretty after the impact, we all understand that there is dependencies. But if there is a delay between the cause and the impact, as you see here, it's usually pretty hard for people to understand that actually legal has a negative impact on SSMP. We tend not to see it, and as the delay is longer, it's actually worse. So in a nutshell, causal diagram, you can't run any simulation, but it gives you very high level abstract understanding, a non-linear view of a system. Archetypes can give you very clear indication how many classical or known issues or potential issues you have in the system. The balance between reinforcing and balancing loop gives you indication whatever the system is meant to do what you're doing. The delays give you indication whether there are potential unseen issues within the system. And that's all pretty simple, straightforward, not too many elements, but extremely useful for getting a high-level understanding of systems. And that's all. That's causal diagrams.